Hi everyone, Dr. Biittner here, and this is my daughter Olivia. Okay, you gotta look in the camera screen there,
sorry,
sweetie.
I'm terrible at making videos.
That's okay. We're gonna work together and we're gonna
And
do our
I'm
best.
gonna be the time part. There, I stole it from you again.
Okay, you did steal it from me. So what we're going to be doing is demonstrating to you the principle of radioactive decay. And to represent those isotopes that are radioactive, that decay into stable forms, such as carbon, which is used in radiocarbon dating, but in uranium series, we have uranium, potassium, argon, looks at the decay of radioactive potassium to argon.
Does time have water in it?
No, time doesn't have water in it. You can have a glass of water if you need
Yay.
it. Okay.
I was thirsty, that's why I asked that.
So what we were talking about is, or what I was talking about,
you
that's okay, is that we're going to use smarties to represent our carbon atoms, okay? And so these are going to be carbon-14 atoms, and Olivia is going to be the time that is going to decay these radioactive carbon-14 molecules. Okay, so let's imagine we have found a sample, no thank you, in an archaeological site that we're going to date for radiocarbon dating. Okay, so it has carbon in it. And when we begin, we have 100% of the carbon in the sample. Okay, so we're going to start with finding out our sample of carbon from our artifact. Okay,
I cannot read.
That's okay, you don't have to read it. So now you're going to count out 20 of these.
I know that. 2, 4, 6, 8. If this was at my school right now, I would originally do my school song.
That's okay.
And 10.
Yeah. Keep
12.
going.
Those are McDonald's. 14.
Yeah.
I know how to count them in grade 2.
Yeah.
16. 18. 20.
Okay. So again, our sample has 20
school merch
carbon 14 atoms in it. Okay. Now Olivia, being time, is now going to decay.
Wait, does time has dinosaurs?
Sure, time has dinosaurs in it. So she's going to decay these, and so what is meant by the half-life is that means that for the duration of the half-life, half of the amount of the atoms are going to decay into a stable form. And so in this case, decay is going to be represented by being eaten. So Olivia, can you eat half of these Smarties? So if we have 20 Smarties to begin with, what is half of 20?
10.
That's right.
I know math.
I know you do. Okay, so now take and eat 10 Smarties. Count them as you eat them.
2.
Okay.
4. I'm not eating them.
Keep eating them. Okay, 4.
6.
Yeah. Taking longer to chew these than I thought. That's okay.
Right.
8. Okay. Now
10.
10. Okay, so with radiocarbon dating, because carbon-14 has a half-life of 5,730 years, that's how much time has passed, and now half of our carbon sample is gone, has decayed into a stable form. So after 5,730 years, we only have half of the carbon remaining. So in this case, we have 10 carbon molecules remaining. Okay. Now it's time for the second half-life to happen, okay? So another 5,730 years is going to pass, which means that half of our sample is now going to decay into the stable form. So Olivia, can you eat half of these 10 Smarties, please? So what's half of
5?
That's 5. So eat 5 more Smarties.
I'm going to save the pink one since they're my favorite color.
Okay.
You know what? My favorite color is pink, so I'm just going to...
Okay, can you please
1, 2, 3, 4, 5.
Okay.
6.
Yeah.
7. Oh, wait, never mind.
No, just 5. Okay?
I have 5.
Okay, so just eat 5. Okay. So, remember, we started with 20. For the first half-life, 5,730 years passed. We went from 20 Smarties to half of those, which is 10. Now, the next half-life has passed, and in that next half-life, half of half has been removed, so half of 10 is now 5. And so that's what Olivia has just done for us. So now 11,460 years have passed. So this represents 2 half-lives in the radioactive decay sequence for radiocarbon.
Everybody, we need logic that we all knew.
That's right. Okay.
We need logic.
Third
5
half-life.
plus 5 equals 10.
That's right. Okay,
And
so
10
now it's going to
plus
get
10 equals
trickier though,
20.
Olivia, right? Because we have only 5 Smarties left at the end of
Do I
our
need
second
to
half
eat
lighting.
half?
Yeah, you're going to have to eat half of them. So what's half of 5?
2.
And half. So can you grab that knife now?
Oh, that's what the knife's for.
Yeah. And now we're going to cut one of these Smarties in half because you can only eat 2.5 Smarties.
This is why I call myself a psychopath.
Okay, great.
Plus, I'm holding a knife
Okay,
now.
so be careful and cut it in half.
We're saving red for last. I want. This is the color of Zompiggy and Piggy, and I'm not impressed.
Here, I'm going to help. Okay, so we're going to cut it in half.
Roblox logic.
Okay. So,
I like dubbing.
Again, one Smartie has now been cut into half, and Olivia is now going to eat half of that Smartie and 2 others, right? So this represents our third half-life in our radiometric decay sequence, right? So again, we started with 20, then over 5,730 years, we were down to 10.
It in half.
Another half-life passes, so now 11,460 years have passed, and we're now down to 5 Smarties. Now we're looking at half of 5, representing our third half-life, or 17,190 years passing. Okay.
Polly, come here.
No, Olivia, it's okay. Now our last half-life is going to pass. Our fourth half-life, taking us to 22,920 years has now passed. And so, Olivia, what's half of 2.5? What's half of 2.5? Okay, what's half of 2 to begin with?
Half of 2 is...
Come on, silly girl.
1.
1, okay? But then we need half of half, so that's 0.25. So again, we're going to use our knife, and we're going to cut our Smartie into half of half, or into a quarter, right? This is getting tricky because now we're down to this tiny little Smartie, okay?
No.
So Olivia has now eaten a quarter, and then she's going to eat one more. So this is all we have left after 22,920
still have one more
years,
M&M,
right?
and
4
a whole
half-lives.
bowl full of them.
Yeah, but we're not going to worry about those. Okay, eat this one. You have to eat that time. Okay. Now it gets even trickier, right? Because now we have 1 1/4 Smarties, or 1.25 Smarties. If another half-life passes, taking us to 28,650 years, we have to divide this again, right? So how do we divide this? Well, now we need to divide our 1 Smartie into half, right? And then we have to take our 0.25 and divide that into half as well. Okay, Olivia, can you eat this now? So Olivia is now consuming...
I devoured it.
The 5th, or what represents now our 5th half-life, or the passage of 28,650 years. Okay, Olivia, what is half of 0.625? Okay.
I don't know that math. I'm only in grade 2.
That's kind of the point. Okay, so Olivia's job is now done. So here, sweetie, you can finish eating this. Okay. Okay, thank you, sweetie. Can you now go? I'm just going to finish this video. Okay.
Can I just stand here?
Sure, you can sit this here and be weird. Okay. So what you've seen is that basically after 5 half-lives, the amount of carbon that was left in our sample, or radioactive carbon that was left in our sample.
You're just like my school teacher.
I know. Just in a second, sweetie. The amount of carbon, or radioactive carbon, or carbon-14 that's left in our sample, or in this case Smarties, is now so small that it's getting difficult to find another half. And that's essentially what happens with radiometric dating techniques. Yeah, we have a tiny little bit, but see how it's even hard to see on the camera. And again, that's the point here, is that our instrumentation techniques are not precise enough to be able to measure after a certain point. And so this is why we refer to the kind of maximum limit of radiocarbon dating as being around 50,000 years ago, is that by that point it's extremely difficult to measure the amount of radioactive carbon that's left, right? We just don't have the instrumentation that can do us. So I hope this helped illustrate that principle for you. Again, we can revisit talking about dating techniques next lab. Okay, so this is Polly. Thank you, everyone.
Everybody knows Polly.
Okay, we'll see you soon.
Look
Take
at
care.
her face. Look
Say
how
goodbye, Olivia.
And how cute.
Say goodbye.
Goodbye.
Okay, goodbye, everyone.
Take Polly with you.